So welcome to the Data Center Alliance Special Interest Group, and I'm going to give you a quick presentation on energy efficiency within data centers, a bit of sustainability, and a few references to standards to see A, what's out there to give people an understanding of what they can be using and probably should be using, and B, maybe to examine where there may be some gaps. So moving through, I'm not going to take too much of your time. I'm going to run through an introduction, understanding data center energy efficiency, which I think is a very misunderstood concept, the standards challenge, the available metrics, as I mentioned, a brief description of what ISO are doing in this area beyond the metrics that we've got, recommended practices, the future, and then maybe a little bit of a crystal ball experience to see if we can throw a few things out there that might be useful. So, first statement, genuine energy efficiency in the data center is elusive. And it is. You'll hear all sorts of people talking about energy efficiency, and generally speaking, they're talking absolute nonsense. PUE is not an energy efficiency metric. Let's just get that out there. It's not. People use it as such, governments use it as such, regulators use it as such, the media use it as such, and actually quite a lot of so-called experts in the industry use it as such, and it's not. All PUE does is give you an indication of the overhead that the building imposes on the IT load. And if you're not on mute, can you go on mute, please, because you're rattling away. Thank you. So where should we be looking? What is true data center energy efficiency? Is it really the building? You know, we seem to be continually, well, we in the media and governments and everybody else seem to be continually blaming the building for being a problem, and then completely ignoring the IT load that sits in the building, which is actually what we're ultimately supporting. As I always say, the building doesn't actually use energy, which is a bit of a sort of an arguably shocking statement, but it doesn't. All the building does is impose an overhead on the load that is using the energy, which is the IT load. So let's think about how we actually achieve genuine data center energy efficiency, and how we ultimately demonstrate to regulators that we're doing the right thing and following the appropriate guidelines. You know, the regulators seem fixated on PUE, and they are. You know, you look at Amsterdam, what Amsterdam's doing, it's fixated on PUE. Well, it's not really helping anybody, is it? You know, it's using a metric as some sort of proxy for energy efficiency, and it's not really working. All they're doing is to some degree impeding their own ability to stay competitive in the global market. And what we're not doing by focusing on PUE is actually ultimately reducing our overall energy consumption. Yeah, we're reducing the energy consumption that the building imposes on the IT load. Of course we are. And we're potentially making cooling more efficient, but we're not actually reducing energy consumption. So we're not actually achieving the thing that it's intended to achieve. So what is a data center, a building, or a service? And, you know, I would argue the data center is ultimately a service. Yes, it sits in a building, but actually what our data center is doing is providing an IT service. It's providing IT service availability. So let's actually measure how effective or efficiently that service is using energy. Let's not, again, focus on the building. And I'm not going to harp on about it because I mentioned PUE too often already. But ultimately, true energy efficiency has to be based on useful work done. How we define useful work in the context of our industry is very, very difficult. It's a hugely subjective thing. You know, what is useful? Are pictures of cats or videos of cats useful? Well, maybe to some people they are, you know, particularly in the whole sort of COVID situation. You know, I'd argue that some people have managed to cope because I've been watching videos of cats. Maybe a little bit strong, but you know, I think social media generally and some of those more frivolous things out there have actually helped a lot of people to a huge extent. So, you know, to call them unimportant is probably a little bit simplistic. Nevertheless, I think we have to consider, you know, how useful the services that we're providing really are. But unfortunately, at the moment, we've just been, you know, as I call it, navel gazing at the building. We're not really dealing with the with the true problem. You know, it's not just an elephant in the room; it's actually an entire herd of elephants in the room, and we still seem to be able to ignore them. And the analogy I use, or I'm trying to introduce on occasion, is the analogy of the house with a shower running in it 24 hours a day. Just because you've got a hot shower running in your house and you're not using it, nobody in the family is using it, but you still got the hot shower running, it's switched on, all it's doing is throwing hot water away. Doesn't mean your house is inefficient. You can have a fantastic energy efficiency rating for your house. It can be perfectly triple glazed with all the insulation in the world. but you don't call your house energy inefficient because you're running a hot shower. It might be more sensible to turn the shower off. Which I think is the analogy I'd like to use with the data center. Let's think about the shower. What are we doing about the hot shower that's running without being used? Let's not blame the building. Let's just not really focus in the right area. So again, regulation should be on not on the buildings, but the IT services. And ultimately, we don't actually measure the energy cost of the IT services in many cases. The buildings become a soft target for media and regulators, and we need to change that. Cloud actually just makes this worse. The problem with cloud is that it obscures to some degree the true energy cost. Ask cloud customers, public cloud customers, whether they actually see the energy consumption of the cloud services. And the answer is invariably no. We do not know how much energy cloud consumes. We have all sorts of hyperscale operators saying that their building's the most efficient in the planet. Well, so what? How efficient are their cloud services? How many instances of their data center architecture are actually out there? How many mirrors of the equipment are out there? How many of those mirrors are switched on and inactive, doing actually very little other than waiting to be used in the event of a data center somewhere else falling down? So the suggestion that cloud services are more energy efficient is probably not true, but actually ultimately nobody knows because we don't see the energy bills for cloud services. Customers don't get them. And I think one of the most important things we can do is start demanding that actually we do see the true energy usage of cloud services. I don't think the hyperscalers would be very pleased with that, but I think it's an essential part of actually improving energy efficiency in our sector. Again, and the final bullet on this is we just need to be having that data. If we don't have that data, we're not really going to ultimately improve our energy efficiency. Standards. We mentioned standards. So, what have we got? Where are we going? The problem with the standards landscape is it's actually very confused. We think of standards as being standardized. Well, yeah, they are to a degree, but unfortunately, lots of people use the term standards when they're not actually talking about standards or true standards. There are all sorts of documents and frameworks and whatever out there that aren't true standards, but that we do reference repeatedly within the sector as being standards. There are national standards. We routinely use US national standards in particular. They are national standards in America, some of them, but they're not necessarily international standards. So why we've chosen to use American standards is a little bit bemusing, but nevertheless we do. And then there are all sorts of other organizations, associations, whatever, that decide that it's appropriate for them to reinvent standards, even though perfectly good standards actually already exist. I'm not going to call out any in particular, but there are organizations out there that either seek to promote themselves by generating what they describe as a standard for the data center sector, doing something useful, or indeed basically inventing something to derive consulting revenue from it, which again isn't particularly helpful because they're creating something else that people reference, which ultimately is just a mechanism to derive consulting revenue, but actually ultimately confuses the market. There's no point in having benchmarks if they're all different. So. Not particularly helpful. I think one of the frustrations is that we do have standards, we do have KPIs and metrics which are arrived at by consensus and debate, and they're not necessarily used, and people in our sector are not necessarily aware of them. But it is absolutely critical that we do have consistent standards which we all reference and depend on. Because otherwise, how on earth do we approach regulators? How on earth do we actually approach anybody and say we're doing a good job? How can we actually say that we are being efficient? How can we actually say that, how are we measuring what we're doing unless we can apply some sort of common benchmark? Ultimately, it's impossible. So we need to do this to avoid confusion and ultimately ensure some level of consistency across the entire sector and across all nations involved in the sector. So, what do we have in the way of sustainability metrics? And I know that one of the questions that Astrid and team had asked originally is, what do we have, and potentially what's missing? Well, this is what we have, some of which is published and some of which is soon to be published. So we've got PUE. Much as I dislike PUE, in terms of it being used as an energy efficiency metric. It is actually a very useful metric. It does give us an indication of the overhead that the building is imposing on the IT load, and that is useful to know. That is a good operational metric. My only problem with PUE is when it starts getting used as an energy efficiency metric. As we've discussed, it's not. But in terms of operating your data center and understanding the overhead that's being imposed, yes, of course, it's very useful. So we then go beyond PUE. Oh, and the other thing is that PUE is no longer defined by the green grid, which is a common misapprehension in the industry. It is defined by ISO IEC, and it is defined by this document. So ultimately, if anybody's telling you that the green grid defined PUE, or that they're measuring or reporting PUE in any other way than according to this document, then they are basically not using PUE, and they're not doing it correctly. In addition to PUE, we've got renewable energy factor, REF. That is a published document, and really all this is giving you a proportion of the energy that you're consuming in your data center that is coming from renewable sources. It's not rocket science. It's just a simple metric. Now, what this doesn't necessarily do is go into the sources of those renewable energy sources. It doesn't necessarily go all the way down the pipe and say, you know, is this from wind? Is it from solar? Is it from whatever? All it's doing is taking the proportion that you are being given from your utility provider of renewable energy. Whether that's truly renewable or not, of course, there's always going to be some level of debate on that. This metric doesn't seek to determine whether it's truly renewable. All it does is take basically the amount of what is claimed to be renewable energy that you're being given by your provider, whether they are a private provider or a public utility provider. IT equipment energy efficiency for servers, fairly self-explanatory, and one of the things we're frequently sort of banged with in the sector is we don't do anything with the IT side of the house, you know, the ICT load. We don't have energy efficiency metrics. Well, actually we do. You know, we've got this with this metric. It is published. Is it the most useful metric on the planet? Does it cover every single aspect of energy efficiency and service? No, it doesn't necessarily, but it's a pretty good starting point, and it's something that we have, and it's available, and actually is very rarely used. The other thing that we that we regularly talk about in the data center world, and probably the IT world too, is the energy inefficiency associated with lack of utilization of the equipment that's actually installed and turned on and working and powered. So again, we have another metric here which tells us about what levels of utilization we're actually seeing across our server estate. So again, something that's very useful. People are regularly talking about, you know, the underutilized resources, or the fact that infrastructure is you know, switched on, not doing anything, or is only at 20% of its capacity. Well, this metric helps you understand what that is, and it's standardized and it's published by ISO. So why on earth people think we need to reinvent something is a little bit of a mystery to me. We then go into those standards which are either about to be published or are in final draft, etc. So we've got energy reuse factor. Again, we talk routinely about how we should be reusing the energy from our data centers. Well, we've got a metric that can measure this, you know, or at least use it to measure and report, probably more importantly. So if we are doing this, then basically here is a metric that you can use to show to others that you are actually doing this, and the degree to which you're doing this. This doesn't give you the ability to do it. It just gives the ability to report the fact you're doing according to a standard benchmark, and actually, you know, is therefore a useful metric to say that yes, we're doing this, we're doing a good job of it, and we're doing this much of it. Cooling efficiency ratio. I mean, this really is more about the efficiency of the mechanical plant, the cooling plant in the data center. Sort of related in some respects to COP, etc. So it's a data center specific version of mechanical cooling efficiency, or cooling efficiency within the data center. Then the last two are things that we've been talking about for some time now, and these have been somewhat delayed in publication, but are now in final draft. Carbon usage effectiveness, so how much carbon we are producing from our data centers for a given amount of either energy or workload, and then water usage effectiveness, same thing. Water usage effectiveness in particular, going back to one of the comments I made earlier, about a year ago, somebody at one of the large, I think it's one of the DCD conferences, actually said, I've got this great idea for a metric. It's called water usage efficiency. We should measure the amount of water we're using, despite the fact that this thing had been in draft for probably 2 years before that comment. So again, people trying to reinvent the wheel. These are effectively out there or soon to be out there. My urge to you, all of you listening, and anybody who's listening to this broadcast, is use them. Look them up and use them. Don't try and reinvent the wheel. Don't use those that people have reinvented. These are ISO standards. These are international. These are available to everybody. It would be useful if we all actually use them and reference them rather than all the other things that are flying around. In addition, ISO have also come up with, or are coming up with, standards that relate more to the sort of the built infrastructure, the facilities, etc. These are actually based on the European EN 5600 standard. They are essentially direct copies at the moment in the published format. These are published, these are available, these documents, but they're currently only technical supplements. They are not actually published standards. They will soon be published standards. They will be different from the documents that are currently out there. But they are not yet technically a standards documents. They are being changed and edited by international teams. So the European documents have been taken as a base and they've been moved out into the international arena, and they are being commented by obviously countries outside of Europe. So it's morphing into something more international. But the basic core content is actually very similar, and the concepts that were originally contained in there really aren't changing. So if you're familiar with tiers or levels, then essentially think of those as morphing into availability classes within this set of documents. Recommended practices. So the EU Code of Conduct, that's out there. We've just had a revision earlier this year, January this year. The 12th version was released. This is regularly updated, routinely updated. Over 100 practices that ultimately will save you energy if you implement them in your data center. It's not a question of if or possibly. If you do take these practices on board and you're not currently applying them, then by applying them, you will save energy and therefore costs. Simple as that. They're tried and tested and they're used by lots of people. Used by rather more people than actually actively participate in the scheme, but nonetheless still a very useful document. The great thing about it is it's free. You can download it, go and get it, use it, reference it, make use of it, because not only will it help save the planet, it'll actually save you some money at the same time. A lot of the practices that were originally incorporated into the Code of Conduct are actually now incorporated in the EN 5600 series, the European standards, the data center standards series, in two technical papers which are published as sort of as adjuncts to the standards. They're not standards in themselves, but they are technical reports which ultimately support the standard series. So the practices that are incorporated in there are, broadly speaking, the same as the ones that are in the Code of Conduct, just written in a different way and in more of a standardized sort of format. But essentially speaking, they're the same things. The future. Again, Astrid mentioned, what's missing, what could we possibly do? I've given an overview of what's available. There obviously are other things potentially in the pipeline, but this little list here is just an idea, and I am quite happy to be shot down in flames in some of these things. They are literally sort of almost to provoke debate rather than actually anything particularly useful. But the one thing I will say is there is it is not possible to have one single energy efficiency metric for data centers. It's been tried. People are still trying. People are still failing. Because of the way we use data centers, because of all the different facets within a data center, because of all the different types of data centers, and because it's actually impossible in many respects to define what is useful work in the data center, then we are really not going to end up with any single energy efficiency metric. We're going to have lots of different things which indicate energy efficiency possibly, but I don't think we're going to have one single metric that gives us that sort of simple number. Again, it's been tried and it's failed. It's failed. And the other thing that we can't do is necessarily string a whole load of existing metrics together to come up with a number that gives us energy efficiency. That doesn't work either. You know, how you weight those numbers, how you bring them together to make them useful, it is not as simple as just bringing together a bunch of existing and agreed metrics. It just doesn't work that way. I think what we do need to be focusing on, though, as I alluded to earlier, is software and application efficiency. You know, I think, you know, software developers in for enterprise applications, be it the operating systems or the end user applications themselves, somehow believe that electricity is free, or that their applications don't consume electricity, or that the servers they sit on don't consume electricity. And certainly that seems to be the way that they code anyway. They don't really seem to be considering the energy burden or the simple cost of it. So, you know, I think there's a huge onus on software applications, operating system developers, and I include network and storage in there, to actually understand the energy consequence of the code they're writing and what it's actually doing. At the moment, I just don't think that happens. We've mentioned cloud. So I think it would be an interesting idea to have a metric that defined how effectively cloud services were being delivered in terms of their energy consumption. Quite how we do that, I don't know, and that's why I'm throwing this out there. Sort of CDE, cloud delivery effectiveness. You know, again, as I said earlier, we don't necessarily see the energy bills for cloud. We don't actually know how much energy our cloud services are consuming. It's all a bit obscured, hiding behind the smoke screen, as I said. I think something like this would be very, very helpful to help us actually, you know, see whether we're comparing apples and oranges. Because at the moment, I don't think we have the ability to do that. Application, talking about end user application delivery effectiveness, watts per transaction. This is probably oversimplifying things a little bit, but many organizations are moving potentially towards saying, what do we do as a business? What sort of transactions do we have? You know, let's think of a bank. You know, how many watts does it cost for an ATM transaction? How much does it cost to transfer to look up your balance on your account? How many watts does it cost to transfer money from one account to another? You know, that's quite specific and quite straightforward. Another one might be credit card transactions. What's the energy overhead of a credit card transaction? Something very, very application specific like that might be quite useful. Now, it wouldn't be a generic metric that would cover the entire industry, but I think within a particular organization or in a particular industry vertical, it might be useful to have that comparison for very, very specific tasks. We can't cover all tasks, but for very, very specific, well-defined tasks, it might be useful to have something that we can actually pin a number on. Network, we talk about network and the overhead of network. People forget that actually, you know, turning photons to electrons and back again and shooting down a piece of glass does actually have an energy overhead. So I think it's important to consider the energy aspects of this, something that's often overlooked. And again, if we go back to cloud, yeah, cloud, great. You know, they've got lovely, efficient data centers, but of course their reliability and resilience requires heavily on network. You know, what's the additional overhead that network imposes in terms of energy versus having it all in one data center, which is probably less energy efficient because it's at a higher tier or availability class. But nonetheless, probably consumes less network energy. So again, where's the trade-off there? And you know, are we sort of hiding behind cloud, obscuring the network costs a little bit as well? And then finally, how do we actually demonstrate to potential regulators that we're doing the right things, following appropriate guidelines, you know, as an industry, minimizing our energy consumption and overhead? Well, ultimately, standardized metrics and KPIs are the only solution. I would caveat that by saying using the right standardized metrics and KPIs are the only solution. You know, don't use things that claim to represent energy efficiency, which don't really help. But ultimately, you know, we have to be using these things. We have to be referencing. We have to be using common, consistent benchmarks. Otherwise, we've got no chance of actually demonstrating what we're doing, or even, frankly, properly measuring what we're doing at the moment. And I think that's a struggle. Finally, sustainability is not just about green energy. It has a huge part to play, but it's not just about basically moving everything to, you know, renewable energy. That's clearly a good thing to be doing, but ultimately it's not just the right thing to be doing. We actually need to be more effective and efficient in the use of the resources that we are using, whether renewable or otherwise. So we can't just move everything to renewable. It's not as simple as that. We just need to get more benefit from the electrons that we are actually consuming, whatever color they are, whether they're green or other. We talked about earlier about embodied carbon, scope 3. You know, we're some way away from actually doing that, but clearly that has to be an ambition. We have to be looking at that. And you know, that's a direction of travel. Certainly, we've got to be looking in that direction. At the moment, that's relatively difficult, if not impossible in many cases. And I think finally, and I've repeated it often enough, is we've got to be looking at the services inside the data center. You know, what are we providing in the way of services? And you know, we need to be stopping obscuring the energy consumption of the services by focusing on the building. You know, we need to move the media on. We need to get them away from the building and say that data centers are destroying the planet because you know, buildings consume huge amounts of energy. Well, the IT services within those buildings do. I'm not sure the buildings do, but you know, we need to basically move away from that if we're actually going to do any good in this sector. That's it. Thanks to the Data Center Alliance and the SIG for inviting me to talk. I am quite happy to be shot down in flames, criticised or even questioned if anybody has anything out there.
Thank you very much, Mark.